All right, we're going to pull back the curtain on a hidden world that honestly keeps us all safe every single day. We're talking about the unseen guardians who inspect the very bones of our world. Let's dive in.
So, take a look at this. You've got bridges, airplanes, power plants. What's the one thing that connects all of them? You might think it's their size or how important they are, but it's actually something much more subtle, something hidden.
Here's the thing. Every single one of them can be hiding tiny, invisible weaknesses. I'm talking about microscopic cracks, little voids, imperfections that, if you don't find them, could grow and grow until disaster. And that's the challenge engineers are up against every day.
So to even begin to fight this threat, you first have to be able to name the enemy. And in the world of engineering, these invisible dangers have a very specific name.
It's called a discontinuity. Sounds a little academic, right? But what it really means is just any kind of interruption in the material. Think of it like a tiny crack from stress, a little air bubble that got trapped inside a weld. Basically anything that isn't solid, uniform metal.
Okay, so here's the million-dollar question. How on earth do you find a flaw you can't see in a part you can't just break open to check? Well, you need a kind of superpower. And that's exactly where non-destructive examination, or NDE, comes into play.
The most important word in that whole definition is right in the name, non-destructive. I mean, the entire goal is to look deep inside a component, find any of those pesky discontinuities, and figure out how serious they are, all without leaving a scratch. Because what good is testing a critical part if you destroy it in the process, right?
So how do they pull off this magic trick? Well, it's not magic, but it sure looks like it sometimes. NDE professionals have this amazing toolkit of high-tech gadgets, and each one is perfect for a different kind of job. It's like a superhero's utility belt for seeing the invisible.
First up, we have radiography. And yep, this is exactly what it sounds like. It is industrial-strength X-ray vision. Technicians use powerful radiation to basically take a picture through solid metal, revealing any cracks or voids hiding inside, just like a doctor using an X-ray to see a broken bone.
Next up is ultrasonics. If radiography is super sight, this is like super hearing. A gadget sends sound waves way, way higher than we can hear into the material. If it's solid, the sound travels right through and bounces off the back wall. But if it hits a flaw, it bounces back early, creating an echo. By listening for these echoes, an examiner can create a map of the inside and pinpoint trouble spots.
Now, what about those cracks that are on the surface but are just too tiny to see? For that, there's a really cool method called liquid penetrant testing. They cover the part in a special bright-colored dye that seeps into any little opening. Then they wipe the surface clean. To the naked eye, it looks perfect. But then they add a developer which pulls the hidden dye back out, and suddenly the invisible crack bleeds a bright color for everyone to see. No hiding anymore.
And for materials like steel, there's another clever trick: magnetic particle testing. They basically turn the whole part into a magnet. Now, if it's a solid piece, the magnetic field stays nice and neat inside. But if there's a crack, the field leaks out. When they dust some fine iron particles over the top, those particles are drawn right to the leak, creating a perfect outline of the flaw. It's so cool.
So having this amazing toolkit is one thing, but just having the tools isn't enough. Using them correctly, consistently, every single time, that's what actually keeps people safe. This is not a field for guesswork. It's all about discipline and procedure. You see, all this work is guided by a huge set of rules, the ASME code being a major one. Think of it like a giant instruction manual that tells you exactly how every single examination has to be performed to be considered valid. This ensures that a test done in one place is just as reliable as one done halfway around the world. And the code is incredibly detailed. You can't just, decide to run a test one day. First, the procedure for that test has to be qualified. That means someone has to write down every single step. Then, an examiner has to demonstrate that the procedure actually works. And only after that successful demonstration is documented and signed off can it be used for real. There is absolutely no winging it. The code even gets picky about the language. You'll hear two words a lot: inspection and examination, and they are not the same thing. The examination is the hands-on work, the person actually using the ultrasonic machine. The inspection is the oversight. That's the inspector's job, to verify that all the required exams were performed correctly. It's a built-in system of checks and balances. And the people doing all this, they're highly trained experts. You don't just pick up one of these tools and start testing.
You have to be certified, and there are multiple levels. The top experts, the NDT Level 3s, these are the people who are so good they're qualified to not only do the work, but to write the procedures and certify other examiners.
Okay, so after all those technical details, let's just zoom back out to the big picture. Why go through all this trouble? Why have these giant rule books and all this intense training? You know, when you boil it all down, it comes back to one simple, powerful idea: being able to find out what's really going on inside a huge, complex machine or structure without having to tear it apart to find out. It's all about being proactive and catching problems before they become catastrophes.
Every time you fly on an airplane, every time you drive across a bridge, every time you just turn on the lights in your house, you are benefiting from the work of these unseen guardians. They provide the silent, invisible strength that holds our entire modern world together.
Which kind of leaves us with one last big question. In a world like ours, built of steel and concrete, could we really trust any of it without the people who have the power to see the unseen? Something to think about, right? Thanks for joining me for this explainer.